Hello, pre-algebra students. Mr. Lawrence here with a flipped lesson. I know it's been a couple days since we've had one, but this one is kind of cool because you're going to already know how to do most of it. There's only a little bit new to it. Today we're solving and graphing inequalities. Now notice that these problems 1 and 2, they look like things you know how to do, except instead of having an equal sign, we have like a less than or a greater than or something like that. Now I know some of you choose to get confused on that. Just remember that less than, if I could spell it right. Oh my dear, what is that say? I don't know. Less than, there we go, is on your left hand. Yeah, less than is on your left hand. If you hold up your index finger and your thumb and make that shape, the less than one is on your left hand. That means the right hand makes a greater than. Okay, less than, left hand. All right, very good. So we are going to treat these, at least in the beginning, just like it's a two-step equation. We're going to solve them just like we normally would. So on number one, my first step is going to be to subtract 5 from both sides. Okay, and when I do that, those will cancel, and I'm going to get 2x is greater than 20, and then I will divide by 2. Divide by 2. Those will cancel. I'll get x is greater than 10, right? Now, I'm not done with the problem. See, when I'm solving an equation or an inequality, I'm looking for all the numbers that make it true. In this case, x is greater than 10. That means my numbers have to be greater than 10. I'm going to show 10 on a number line. And I'm going to show a number right before 10. And I'm going to show a number right after 10. Now, answer me this. Which one of these numbers makes it true? Is 9 greater than 10? Of course not. Is 11 greater than 10? Why, yes, it is. So somehow 11 has to be included in my solution. You know what else has to be included? 12, 13, 14, 15, 16, 17, 18, 19, 11 and a half, 12 and a quarter, 10 and 3/5. All those numbers have to be included. Here's how we show it. First of all, we check to see if there's an equal sign. If we do not see an equal sign, we make a point that is open. If we do not see an equal sign, we make an open point. If there is no equal sign, we make an open point. If we don't see an equal sign, there is an open point. And then we shade in the direction of the numbers that make our statement true. Notice I didn't shade towards 9 because 9 is not greater than 10. I shaded towards 11. All the numbers that are bigger than 10, including 10.00000000001. That's bigger than 10, isn't it? That's in my solution. A million's in my solution. A Google. 0 is not in my solution. And there you go. Let's try another one. Get a little practice here. Got a two-step inequality. This time it is equals 2. We'll see how that matters in a second. I'm going to add 1 to both sides as my first step. My new inequality becomes 12x is less than or equal to 12. I'll divide both sides by 12. X is going to be less than or equal to 1. All right, so I'm going to come to my number line. I'm going to show the number 1. I'm going to show a number right before it. I'm going to show a number right after it. Okay. Excuse me. Because there's an equal sign, I need a closed point on number 1. Why? Because 1 makes it a true statement. 1 is less than or equal to 1. Yeah, it's equal. Now, does 0 make this inequality true, or does 2 make the inequality true? I think 0 does. So I'm going to shade in the direction of 0. There we go. That's supposed to be an arrowhead. All of a sudden, I'm having trouble drawing. Okay, so that really looks bad. Hold on one. I don't know that looks a whole lot better, but you get the idea. We shade towards the numbers that give us a true statement. All right, let's check out 2 more here. On this one, my first step is to get rid of the 6. The 6 is a positive, so I'm going to subtract 6 from both sides. And then I will get Negative 3x is greater than 12. Going to divide by negative 3. Divide by negative 3. Now something very special happens here when I divide by negative 3. Of course, these are going to cancel. I'm going to get x, and I'm going to get negative 4. But whenever you divide or multiply by a negative, the inequality flips. When you multiply or divide by a negative, the inequality flips. When you multiply or divide both sides of the inequality by a negative, the inequality flips. In other words, the greater than becomes a less than. Whenever I multiply or divide both sides of an inequality by a negative, the inequality flips. So now that I have this, I'm ready to go to my number line, and I've got to show negative 4 on there. And I know a number bigger than negative 4 is negative 3. A number smaller than negative 4 is negative 5. And then I'm going to have an open point. Blake, why is there an open point? Yeah, you got it, Blake. It's because there's no equal sign in the inequality. It's just a plain old less than. Now, what number makes this true? Is negative 3 less than negative 4? Ask yourself, would you rather owe somebody $3 or would you rather owe them $4? I'd rather owe them 3 because I owe them less money. Therefore, as soon as I can pay them off a little bit sooner. All right, so since negative 3 does not make it true, but negative 5 does, I will shade in the direction of the negative 5. And there's my arrowhead. All right, so that's it. This stuff is pretty darn simple if you ask me. All right, now on this one, first thing I'm going to do is I'm going to distribute. Now my inequality is not going to flip on this one because I'm not multiplying both sides by a negative. When I distribute, I'm going to get negative 6x minus 10 less than or equal to 14. All right, I'm going to add 10 to both sides. Add 10 to both sides. I'm going to get negative 6x is less than or equal to 24. I'm going to divide by a negative. Divide by a negative. Whoop, 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 whoop. When I do that, I'm going to get x is greater than or equal to negative 4. Yeah, because I multiplied or divide by a negative. So in this case, I'm going to show negative 4 again. I'm going to show negative 3. And I'm going to show negative 5. I'm going to need a closed point. Why is that, Ariana? Because it's equal to. And then I'm going to shade in the direction of the numbers that make it true. The numbers larger than negative 4 are to the right of negative 4. And there you go. That's your lesson for today. All right. Hope you guys come in Monday ready to go and do a formative assessment. And Mr. Lawrence will talk to you later. Goodbye, everybody.